Good morning. Good afternoon. Here is the Energy Transfer Challenge. So, working with your team, your goal is to complete this kind of game activity, trying to identify how many ants, frogs, and hawks can survive in an environment based on how much energy is available in that environment. To complete this game, we need to identify the clues we have available. So the information we have available is that the habitat starts with 10 million calories from the sun that goes to the plants. Again, that's the starting point. Just focus on that. Our habitat starts with 10 million calories that the plants have created using sunlight, right? And you see that here at the bottom trophic level. This is the bottom trophic level, and we know that the plants have 10 million calories available to them. The next step is to decide how many calories are available at the next trophic level. This next trophic level would be organisms that would eat the plants. So we have to look up here in which organism is the next trophic level. Which organism here, ants, frogs, or hawk, would be placed at this next trophic level? Which consumer would be placed at this next trophic level? We need to identify that. We need to also identify what the third trophic level here would be. Which organisms would go here? Which organism is going to eat the organism that was here? Which ones are going to consume and get the energy from the trophic level down here? And then what would be the top trophic level? We need to label these trophic levels and recognize that all of the organisms are surviving based on the original amount here. So the environment has, again, 10 million calories starting at the very bottom trophic level. These are our producers, the plants. So now that you've kind of figured out which organisms you're finding at each trophic level, and we're just doing one species, right? There's only one species of ant or insects. There's only one species of frogs. There's only one species of hawk, right? Now, an environment's more complicated, but we want to simplify it. So you just got to figure out who goes here, 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 and here. And then we'll know how much energy they have available at each level, how many calories they have. And that's the first step. Based on the original 10 million calories down here at the producer level, we now have to calculate energy at each other trophic level. So we have to calculate energy at each trophic level. How will we do that? It says 10% of calories is getting passed on from each, and we'll put TL for trophic level. So this is the first trophic level, and it says 10% of calories are going to get transferred to the next trophic level. To figure that out, we have to look at this right here. It says only 10% of energy is transferred to a higher trophic level. Well, there's 10 million calories here. What's 10% of 10 million? We have to figure that out, and we'll put that up here at this next level, which you should already have figured out what organism would go here. What organism is going to eat the producers or the plants? To calculate it, so what is 10% of 10 million? Well, in your calculator on your phone, you would get 0.10. 0.10 equals 10%. So the calculation is 0.10 times the energy at that lower trophic level. So to calculate the calories available here, we need to take this lower trophic level energy, which is 10 million, and times it by 0.10, which is 10%. The number we would get is the energy received by this next trophic level. So it'd be 0.10 times 10 million, and that value would be placed at this next trophic level above. And you repeat that each time you go up to figure out how many calories are available at each trophic level. You should recognize, if you're doing the math correctly, you should see calories getting diminished, or there should be less calories each step along the way. So after you do the math, the calculations, you should find that each trophic level is getting fewer and fewer calories for themselves. Right here, we took 10 million, we multiplied it by 0.10 or 10%, and we figured out how many calories are available at this trophic level. Then we would then take this amount and use it to decide how many calories are getting transferred up to this next one, which would only be 10%. So 10% of this one goes here, 10% of this one will be available to the top consumer. All right. Once we figure that out, then we're ready for slide 2. So once we figure out how many calories are at this trophic level, how many calories are at this trophic level, and how many calories are at this trophic level, then we're ready for slide 2. Let's go on to slide 2. All right, it says how many insects can survive based on the energy available and their food needs. So how many insects can survive based on the energy available at their trophic level? And here's the hint. It says you need to decide if adding, subtracting, multiplying, or dividing the ant's energy needs to the trophic level energy available will provide you with the correct amount of individuals possible for each trophic level. So, you need to know how many calories are available at the trophic level of the ants. And based on how many calories are available at the trophic level for the ants, you then have to decide, am I going to add, subtract, or multiply or divide how many calories one ant needs? It says here that insects need 20 calories. So each ant needs 20 calories to survive. So we have to figure out, well, if one ant needs 20 calories, how many ants can survive? Like, how many ants can share all the calories available at their trophic level? So this is where your team has to think hard, and you have to decide. Well, you should already know how much calories are available at the trophic level of the ant. If you don't, you need to pause and go back to the earlier video and try to figure out where should the ants be here. Once you know where the ants should be, then you'll know how many calories they have to share. And if each ant needs 20 calories just to survive, and you know how many calories are there for all the ants to share, you can then figure out and calculate how many insects can survive at their trophic level. You'll know how many can survive there, and that'll tell you the population. You'll end up knowing the population of ants, because you know there's only so much energy they have to share. And once they run out of that energy, no more individuals can exist with the ants. Their population can't be any bigger because they just don't have food to share anymore. You just have to decide if adding, subtracting, multiplying, or dividing these two numbers, what the ant needs and the energy available at their level, is. So do you add how much energy an ant uses to the trophic level available? Do you subtract the energy the ant needs to the amount available at its trophic level? Do you multiply the energy available to the ant and the energy available at the trophic level? Or do you divide energy needs of the ant, the 20 calories, and the trophic level? So are you going to use addition, subtraction, multiplication, or division to calculate the energy needs of an ant and the trophic level that they live in or that they exist in? Take time to discuss this with your team. Once you come up with a solution or an answer to solving this, and you feel confident with it, and all your team agrees or forms a consensus, the next task to do is to follow that and do it the same for the frogs and the hawks. Once you come up with this technique here, you apply it to the frogs and the hawks. The final task to do is to label your pyramid with the correct population number for each species. So you need to draw this trophic level pyramid. You need to show at each level how many calories were available. This part you calculated at step 1 here, the first thing to do. So you knew how many calories were available at each trophic level. And then the last thing to do is how many individuals could exist here, 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 and here on those calories there. So you end up, when you're done, you'll end up with a pyramid or a trophic level pyramid that shows how many calories are available at each level and how many organisms at each level can exist based on how many calories are available. Finally, in your notebook, you need to explain your methods for solving this energy transfer challenge. So how did your team work together to solve the energy transfer challenge? I specifically want examples of your math calculations. So I want to see the work filled out for step 1. I want to see the math performed for each trophic level. So show your work for each trophic level calculation. That's step 1, right? Show this. Show the calculations there in your notebook. Secondly, I want to see the math you've shown for step 1 and 2. Show that work. Show the work. And then you're done. Good luck.